All right, a rectangle that is x feet wide is inscribed in a circle of radius 13. So express the area as a function of x. So area equals length times width for a rectangle. And then we can represent the length right here is kind of given to us. That's x. And this would be the width, or vice versa. It doesn't matter what you call length or width. So I do know the hypotenuse. I do know this is called x. So I'm going to use my Pythagorean theorem. I'll give this a name for now, b. And we got a lot of letters here, but the goal here is to have L and W represented by x somehow, some function of x. So the length is just x by itself. So we need to get the width, this distance, as a function of x. And we can do that with Pythagorean theorem. So if I set this up, x squared plus b squared equals 26 squared. If I solve that for b, then it should be in terms of x. So b squared is 26 squared. Subtract x squared from both sides. Take the square root to solve for b. And it's the square root of 26 squared, I think, is 676 minus x squared. Okay, so now my area is 676 minus x squared times x. Now, what's the domain of that function? Well, there's two ways to think about that. You could solve this equation, 676 minus x squared. Remember, when you take the square root of something, it has to be non-negative. So typically we would do that. But in this case, it has to be positive because it represents a distance. So we can remove the underscore part, and it has to be positive because it represents some kind of length. That is, this side is a length, so it has to be positive. So you can solve that, and that should give you add x squared, take the square root of both sides, and x has to be less than, I know it's backwards, less than 26 if you root both sides. So x is less than 26, but also x itself would have to be positive. So that's why it's between 0 and 26. Okay, so that's the domain. Another way to think about that is without doing all this math, you can look at your picture and say, well, what is x? What's the domain of x? It's got to be greater than 0. But also, if you just kind of focus on this triangle, if this is always 26, x will never be greater than that, right? Even if you stretched it out and this side got small, then this distance x here has to always be less than 26 because the hypotenuse is the biggest side. So x would always have to be less than 26, but also greater than 0. It's another way to think about the domain. All right, now onto the graph. If I graph this guy in Desmos, I get this. So it's x times the square root of 676 minus x squared, and this is the graph. And in my math lab, it's asking about windows. So let's run through it real quick. X square root of 676 minus x squared likes that answer. We talked about the domain. It's the next question. That's this guy. And now for the graph. And you can do this on your calculator. These are kind of graphic calculator graphs, but I did it in Desmos, and these are the windows. Okay, so it always goes x min, x max, y min, y max. Okay, so you can mess around in Desmos with those windows 0, 26, 0, 360 by clicking on, oh, you can't see it. Let's see here. By clicking on this guy, and you can type in your max and mins. So if I did that, 0, 0, 26, and then it gave me kind of two options in my multiple choice for y, 0, and one of them was 360, I believe. And I get this window. I can zoom out a little bit, but anyway, you get the idea there that this is how you do max and mins in Desmos, and then they just changed because I clicked on my zoom button. Right, that's pretty close to what you're looking at in my math lab, and that's pretty close to 0.26, 0.360. So I think that's the correct answer. If you're using a TI-83, there's the same option here. It's just, I think you go to window is the function, window, and then you can type in X max, X min, X max, Y min, Y max. Okay, and also on your graphing calculator, there is a max function that'll tell you what this point is here. Okay, so it looks like, well, Desmos kind of goes to it, right? It looks like 338 is the max area. Um, let's see, that would be this graph. Okay, and for the max area, you'll have to, what dimensions maximize the area of the rectangle? So I'm pretty sure in Desmos that is the max area, just because as you move along the curve here, you don't get anything greater than 338. So algebraically, if we wanted to solve that, it looks like my max area is 338, right? And then I could solve this equation to get the max, or I could try and use those operations on my graphing calculator to find what the input would be for the max area there.